right, guys, we're here with Eman.
What's up?
And we're doing another part to the 1,000 horsepower engine build video. So we got the short block on the stand, and we're installing the 14 millimeter studs. So I'm going to show you guys these. These are 14 millimeter studs by IAG, and these are the biggest stud you can physically put in an EJ block. These things are massive. The video really doesn't do justice, but show you guys how big these are. So we're over here prepping this block, and sorry the light is a little too much for you guys, but we're prepping this block and we're putting these dowel pins in, and these little dowel pins that go on the block here had to be actually bored out because the stud is so big, and they barely slip through there. So pretty insane, you know, how big these are. I mean, look at that side profile. So this is their Firelock series block. It's got the receiver groove cut in the cylinder deck here, and actually creates a lock between this and the head. So blowing head gaskets are a thing of the past with this motor. If you blow a head gasket on this, I don't know what to say. But we're going to keep putting the studs in here, and then we're going to put the cylinder heads on, and then we're going to measure the buckets, get the cams in, and move forward. So I'm going to do a little time-lapse video for you guys, and here we go. So we already got the other cylinder head on the other side, but I wanted to show you guys these gaskets and what's special about this block. Obviously, we talked about the 14 millimeter head studs. These things are monsters. These little guides, the little dowel pins on the block, we actually had to get these from IAG because these are drilled out to fit these studs, and there was a little bit of a special procedure getting this stud through the sleeve and into the block threaded properly. So it takes a lot of patience and it's tedious, but you got to take your time. But this is what makes this block special. So this gasket's made by Athena. You've seen me use these before on my other builds. We use a Cooper fire ring version of this on my blocks that I do. Works really well for me. This takes it a step further and is even better. So the difference is it's the same manufacturer, but the rings on this one, they're a lot different. They're way thicker, and they don't have a protruding edge that bites into the block. They just sit in the block, and they basically lock the combustion chamber for the cylinder head to the block. They create a much tighter seal. So I don't even know if it's possible to blow one of these. I mean, anything's possible, I guess, but I would be very surprised if this fails. So this is basically the only thing you can do on an EJ to keep the heads on the block at any power level this thing's capable of. So it is pretty cool. I have been interested in it, and IAG did a pretty cool job when they engineered all this. But so what happens here is this ring sits into this groove that was machined into the block. You can see this groove here. And what this does is when you set these rings in here, this is your fire ring. So normally it's built into the gasket. Now if you look at the gasket, there's nothing. All that's left now is just to seal the coolant jackets and the oil away from the cylinder. So this is basically just a rubber gasket now. I've always wanted to see a multi-layer steel version of this if it's possible with this technology, but I'm sure there's limitations in manufacturing and whatnot. But this works really well. So this gasket here, you're just going to basically drop this on. Just like that, and it fits around these rings. You just got to be real careful and make sure these rings are pushed all the way in. And you can see the gasket needs to be kind of pushed down to get this to seal good. All right. Now basically what's going to happen here when we torque these heads down, this gasket is going to compress naturally. So just want to show you guys that little bit there. Now we're going to get the cylinder head on, and we have to thread the other two middle head bolts in after the gasket's on the block, and then we're good to go. All right, so we got the heads torqued on the block. Now we're on to the next step. This is the most tedious, time-consuming process on a Subaru head when you're building these motors. This is never really done right by a lot of people because it's just time-consuming and irritating, but this has to be done right, especially when you're doing a set of aftermarket cams. The window and the margin for error gets even smaller. So basically, in order to do this correctly, these buckets, they have numbers inside. So you can see there that number, that's basically the thickness of the bucket where it contacts the valve to the face of this. So there's 100 different numbers from Subaru available. So in order to do this, you have to figure this out, which buckets you're going to need to get the valve clearance and valve lash you want. So in these big motors with these big studs and all this stuff going on, I always torque the heads down to the block first and get it final torque, and then I check this, because what I found in the past is that if you don't do that, this changes when you torque the head down to the block. So a lot of people will send this to the machine shop and they'll get these done on the bench, they put them on their car, and then they wonder why they're ticking or not, the lash isn't where it should be. Well, that's because they need to be torqued to the block to do the final measurements, or things are going to change. So I always torque them down the block first, then I check them all and I set them all. So, and also, since we're doing new cams on this, it's going to get 100% new buckets every time. Never reuse buckets when you're doing new cams, because this surface and the cam lobe are a relationship. They wear together. And over time, the cam will actually wear into this bucket and create a wear pattern on this that you won't be able to see with your eye. I mean, you can kind of tell if you look. You'll see a little bit of a circular pattern there. It's going to be really hard for the camera to pick up, but when this bucket's in the head, when it's inside this head, when the engine's running, this bucket is actually supposed to rotate, and it circles like this, and that's what gives you that little bit of pattern every time the valve comes around and touches it. So if this doesn't rotate smooth in here like this and doesn't go back and forth, you got a problem. That's another issue, you know, you got to watch out for. So got to make sure everything's smooth. You got to make sure these buckets literally are just butter when they drop in and real smooth and rotate. So now what we're going to do is we got to figure out what our lash is. We're starting over. We're starting from scratch, which is the hardest part. So what we're going to do is we're going to take and we're going to drop these used buckets in just to get our measurements, and then we're gonna find out. Now, you gotta make sure the buckets you're using for your measurements are in good shape. Relatively low miles, don't have any weird wear on them, because that will change your measurement. These buckets were perfect. There was no issues with these heads at all on the other cams. The wear was amazing. So we trust these buckets are correct. Now, you can go a step further. You can measure these buckets with a what's the word I'm looking for? A caliper or micrometer. You can get in there and actually measure it and make sure, if you really want to be, you know, careful, which is a good idea if you're building a really high-end motor. So let's get started on this. I'm going to start basically getting my baseline. I'm going to get a piece of paper out, and I'm going to basically drop each one of these buckets in there, write down the number in each hole, and then I'm going to measure the valve lash and what I get, write that down on the piece of paper, and then the difference between that and the measurement we want is going to be the correction we have to make. And there's a little bit of math involved, and I'll show you guys the easy way to do this. So I'm going to go ahead and start doing that now, and then we'll come back. I'm in there, and we got the buckets in there. So I wrote down all the numbers of the buckets that are in those holes to the corresponding holes. Now we torque these caps down to 14 foot-pounds with the torque wrench. It's extremely important. These are torqued to spec. We only need the big bolts here. We don't need the ones on the end, because this doesn't affect the cam clearance because we're torquing here. So now that the cam's in there, it should be nice and smooth. We're going to go ahead and take the measurement that's in between here. So there's a measurement. You stick this in there, and the measurement between the base of the lobe, not the highest lift point, but the base right here at the bottom, is where you're going to take your measurement. And the clearance between this is our valve lash. So on these, a lot of the cam manufacturers will tell you to go pretty tight. I go a little bit looser. I've got my own recipe that's worked for me over the years. I've had lots of cam failures in the past, and they were never with the specs that I use. So I have my own reasons. You guys can follow the cam cards if you want, but I don't go that much looser. I just go just a tiny bit. And you know, it's what I've found with this Subaru motor is it's better to go too loose than too tight. So I'm going to take these measurements, I'm going to write all these down and measure all these lobes out, and then I'm going to show you guys the math involved. This one here, look at our gauge. Basically we got 8 and 10. This is a go, no-go gauge, so down at the tip this is 8, up here is 10. So the tip is the only thing that's sliding in. That tells me we're at 8 thousandths. Next one we're going to measure. 8 doesn't fit, so we're going to go down a size. 7 slides in, so we're 7 thousandths. This one's hot dog down the hallway, so we're going to step it up. We're going to probably go up to 10 or 12 on this one. No, 10 doesn't fit, so we're looking a little bit less than that. So we'll see if we got 9. Yep, we have 9, and 10 doesn't go, so that's 9 thousandths. Okay, this one's too tight, so we're going to come down. And we're going to go 7. So this one we have 7 and 8 doesn't, or 9 doesn't go, so it's looking like we're about 8 on that one actually. Double check. Oh, 7. So we're 7 on that one. So this one will be 0.23 millimeters. Okay, so now that we've got their measurements here on paper, so you guys will see 481 bucket that's in that hole, we got 8 thousandths. I've converted it to millimeters because you need to convert to millimeters. It makes things a lot easier. The reason why is because these bucket numbers are in millimeters. So that just makes conversion a whole lot easier. So from what we got here, we're not terrible. These are actually really close. I mean, as far as the cam card goes, we're right in the ballpark of where they said it should be. But since we're doing new lifters anyways, I'm going to adjust these to exactly where I want them for my recipe and my specs, and then we'll be good. So basically what we're going to do now is, if you look here, so let's say we're at 8 and we want 10. So there's a difference of 2 thousandths of an inch. So you're going to take that 2 thousandths and you're either going to subtract it from the bucket or add it. It's basically that simple. So if you're basically here on the tight side, you're going to need to subtract it from the 481, and whatever number you get there, after you convert it to millimeters, of course, will tell you the exact bucket you need to order. So that's how you do it. All right, so we're back on the cylinder head assembly on Emanuel's long block here. We got the other side all done, but I'm going to video this side for you guys and show you the little tricks and tips here. We got all the new buckets we ordered brand new from Subaru. So all those sizes came in today right here. You can see inside. I don't know if you can see that they have different numbers. So I went ahead and did all the math yesterday, showed you guys, and we ordered all brand new ones from Subaru. So now what I'm going to do is I'm going to go through my blueprint sheet here. And my blueprint sheet is where I keep all my measurements and figure all this stuff out. So that's going to tell me where the buckets need to go today. So it's my little cheat sheet, I guess you could say. So first one we're going to do is going to be a 475. So we're going to come in here and we're going to grab a 475, as you can see. And what we're going to do is we're going to get a little bit of assembly lube, not a lot. We just want a very light coat on the outside of the buckets, basically just for the first start. And then we're going to drop this in. It should be very smooth, and it should also spin freely. We're going to rotate them 360 degrees in here, And what that's gonna do is that's gonna get the lube on all 4 corners of the contact spots. I mean, it's a circle, but realistically, there's a little bit of touching here, 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 and here, but we wanna get that lube all the way around. So we're gonna go to the next one. And the next one's gonna also be a 475. I got a little bit of lube left on my fingers here, so we're gonna go ahead and swirl that around a little bit. We're gonna drop that one in. Just like that. Give it a spin. Feels amazing. We're gonna do the next one, 481. And get a little bit of lube on that. Yep, nice and smooth. Then we're gonna do 479, it looks like, which is this guy here. A little bit of lube on there. Nice and smooth, so we're looking good. Then we got the last ones here. We're gonna do a 481. We're gonna need a little more lube. And just a note, there is lube on all of these guys as well, on these little keepers. I guess it's not really necessary, but call me superstitious, but I always put a little bit of lube on the tip of the valve between the bucket just for first start. Because for first start, we just want things as smooth as possible until oil pressure comes up, because sometimes putting these engines together, they don't always start right up because you have other issues with other components, and you'll be cranking on it and it'll be dry, and it's not really a good situation. So what this lube does that we put in all these places is this is our oil until the engine's running at a high enough RPM where it can get lubricated on its own. So this is our only protection from some serious wear issues on a first start before the oil pressure comes up. So that's why we have to use really good lubricant, and we have to use a lot of it and in the right places, because you can have a brand new build like this fail right away if it doesn't have any pre-lube in it and it doesn't get any oil pressure, or coils get hooked up backwards and you're cranking on it and it's crossfiring and you got no oil pressure yet. I mean, lots of bad things can happen. Stuck injector, it hydrolocks. I mean, I've seen it all. So now that we got all these lifters in here in the right spots, we're gonna go ahead and lube each one of these individually. This is very important for the first start. So we're gonna use quite a bit of lube on here. And we're gonna basically come on here and we're gonna coat the entire bucket with a nice coat of lube like that. What this does is the cam is gonna hit that spot when it comes around for first start. And so we wanna make sure that when there's no oil here and the cams are coming around, the cams aren't broken in yet. They're brand new, so they're very delicate and fragile. So they're not hardened yet from getting hot and doing the break-in procedure yet. So this lube is critical because you can literally start scarring up the buckets and the cams right away on first start. And it's not a good situation. Your cams will end up going flat on you and causing all kinds of issues down the road. So we try to put as much lube as we can in the spots we need to. We're also going to lube up these cam journals where the camshafts sit and ride in the heads. We're not going to go heavy with these journals. We're just going to go nice light coat. I'm just going to get a nice little surface in there for the cams to float on. You can see there. Looking good. And now we're going to grab the cams. We're going to lube the cams up too and drop those in. All right, so the cam itself, the lobes are all going to need to be lubed separately, the journals and pretty much all the shiny parts. So what we're going to do is we're going to grab a good amount of lube and we're going to put it all the way around the cam lobe to protect it. This is what I always do on every build that has new cams, especially. Even on a build that's got used cams and you're putting together for the first time, I still put a little bit of lube on the cam because, like I said, you never know how the first start's going to go. I mean, sometimes we turn the key and everything works perfectly and fires right up and we get oil pressure within the first 5 seconds, but sometimes doesn't go so smooth. We can't figure out why the car won't start. We're cranking on it for minutes over minutes, and there's no oil pressure, and things start getting tight and galling and binding up, and it's not a good situation. So we definitely try to just take our time here and go the extra mile and drop some lube on here. And basically, we're trying to prepare this motor for the worst. That's basically what lubing all these components is doing. We're gonna do the same thing on this cam. And the break-in assembly lube that we use is Joe Gibbs. It's Driven is who makes it, and it's some of the best lube I've ever used. I've used a lot of lubes, and this one is very sticky. Has a whole lot of ZDDP in it, zinc, and it's really awesome stuff. I've had very, very good luck with it. I've never had an issue. This was actually recommended to me by one of the reps at SEMA years ago when I went to SEMA and talked to the guy about Subarus and the cam setup, because these are actually a flat tappet cam setup, and I know a lot of people won't know what that means, but all the muscle car guys out there will know exactly what that means, because this is very old cam technology. This is actually you know, it is a little bit newer than the old school V8s, but it's the same flat tappet kind of deal where you have wear surfaces that have to wear into each other, and if they don't temper and wear properly, they don't mesh well and they go flat. Same thing with an old V8 with a flat tappet cam. You got to run it at like 2,000 RPM for 30 minutes with high zinc oil in it for the anti-wear. Same kind of deal here. We have to break these cams in for 20 plus minutes. Same deal. They're not a hydraulic cam like a lot of newer engines. Hydraulic cams, you don't have that issue, but this is kind of a hybrid flat tappet lifter setup, so it is a little different than most engines. So we got the cams in there. Everything's looking real good, lubed up. The other thing you always got to make sure is you always want to grab this cam and you want to make sure it's smooth. It's real fluid when you can turn it by hand. That's a good sign that the cam journals are good and everything's in there right, nothing's bent. But you definitely want to do that check. If that's not right, you got to figure out what's wrong. You cannot assemble it. If you assemble it, bad things will happen on first start. You can actually get a cam seize up in the head, and then your timing belt breaks, and all your hard-earned money that you put into your heads and your block are gone before you even know it. So I've actually seen that happen over the years with some heads we had issues with, and you know, trying to make a race and it's late and you just want to go and you know, you just send it, and unfortunately I've been bit before. So you only takes one bad experience to open your eyes with this kind of stuff. So we try to you know, make sure everything's as perfect as possible. As bad as we want to get this thing put together and done, if something isn't right, you have to stop. You know, I know that a lot of people want their cars back. I get it all the time when I'm out here in the garage late at night assembling a motor like this. Guy wants his car back, he's got a deadline. Something's not right, and I pull the plug and I stop and I push it out another week. Something else isn't right, I push it another week. And people get upset, but you know what? At the end of the day, I'm doing the right thing, because I know when my engines leave my garage, no matter how long they took, they're right. And that's what matters the most. So, you know, some people might not agree with that, but that's just that's my motto. If it's not right, it doesn't leave my garage. So, all right, well, we got those cam caps just on there, just basically snug. And now what we're gonna do is we're gonna get the cam case. So I'll hand this off, Emanuel, go grab that. So this is the cam case right here that goes on the cylinder head. So those are the cam journals, bolts that hold them on. Now there's silicone that goes all around this in the right spots to keep this sealed. So I'm going to show you guys where the silicone's supposed to go. So I'll give you guys a little step by step here. You want to hold this camera for me, man, so I can do my thing. So what you got to do, the main thing when you're doing these cam cases to prevent leaks is you got to keep them clean. You got to get all the old gasket material off, and you got to make sure they are as clean as they can be. That is the biggest thing, because RTV will not seal if the surface is not clean. Now you see here, a little spot there got missed, so this needs to get cleaned up. So you want to go clean that up real quick? So E-Man's going to go scrub that one more time, because that right there is a potential leak, and that's also in an area that is very, very potential. So on these heads, the problem areas are right here. These rails, these are guaranteed to leak if they're not clean, they're oily. the preparation's not done right. They will always leak, and you'll think it's a cam seal, and it's not. It's actually the cam case. I see this all the time. And so you really got to take your time and keep this area clean, because when you're assembling these heads, it's very easy for oil just to get squirted out real quick in this spot. And then basically what happens is you go to put your silicone on, and your silicone will not seal because it won't take to the surface, because the surface has oil on it. So you want to make sure this whole surface is clean. And what he's doing here is he's using a piece of Scotch-Brite by hand, and he's just scrubbing it, which is completely acceptable. It's actually the best way to do it because it doesn't remove any material. So yeah, we're gonna get that cam case cleaned up, and then I'm gonna apply the silicone in all the right spots, and then we're gonna have to torque all these caps in a pattern. There's a whole procedure for this. So the long block's looking pretty good though. It's coming together slowly but surely. I've had a couple setbacks that have taken us a few more days than it should have, but hey, when you're building a motor for 1,000 horsepower, I mean, you can't skimp on anything. Everything has to be right. So the time we spend now is going to save us a lot of heartache in the future. So I know he's anxious to get it back and is wanting this thing done like tonight, but I keep having it done
last week.
Yeah, I keep telling him, I was like, every little step that we skip, we can't. We have to do this right. You know, if we're building an engine for, 400 horsepower, okay, we can cut some corners, but when we're asking everything that one of these can physically do, everything has to be absolutely perfect. There's no margin for error anymore, because you guys have heard me talk about this. When you're pushing the limits of every component in the engine to its limit, that's when things get sketchy. And we are definitely going to be pushing every component of this engine to its physical limits. So if anything's not exactly right, it will show. So you got that thing all cleaned up. All right, so E-Man just cleaned it up. Looking really good. I like what I'm seeing. All right, so now what we're going to do, go ahead and hand this off to you. I'm going to go ahead and wipe these rails down again and make sure they're clean. And the first step is going to be to put the lube on the journals. I'm going to grab a little bit of lube. I always like to do this step first before I put the silicone on, in case some of this lube squirts out where it shouldn't. We're just going to put a little dab on each one, then we're going to rub it around. Okay, we're going to check again. Looks like everything's good. Now what we're going to do is we're going to use, I like to use Ultra Gray Permatex. This is what I use. It works really well. Some people like the black because it's easier to clean, but I find this seals much better and lasts longer. So basically what we're going to do is we're going to do these rails. We're going to go around this front bolt hole, which is very important. Like that. Just like that. So if you guys look at a close-up here, this is where the silicone should be. That's it. We're going to come over here, we're going to put it down. Now what we're going to do is we're just going to set this on here, give it a little tap just to seat it, just like this, right? Then I'm going to grab these bolts. And all I'm going to do is I'm just going to run these in just barely snug. Show you why. Literally just barely snug. Okay, now what we're going to do is we're going to put the cam seals in first before we torque those caps down. And this is key because those rails have a little bit of a bite on these cam seals and keep them in place. So if you torque those caps all the way down and then pound these seals in, that will work. But I find that you can get potential leaks because there's a little bit of silicone and this thing squeezes together with this cam seal. So I leave it like this so I can literally just push these in by hand. Make sure they're bottomed out in their holes like that, right? And I put lube on the cam already, which is going to lube the inside of the seal. So you just roll these on real nice like this. And you're just going to push these in by hand. And they're going to seat real nice like that, right? Now we're going to torque the caps down to spec. And once I do that, basically that's going to hold those cam seals in very tight. A little snug. See the silicone squeezing out on the sides, that's a good sign. And then what we're going to do is we're going to torque these basically from the inside out. So we're going to start with the centers. It's 14 foot-pounds on these. We're just going to get these snug real quick. We're going to go around, just get them a little snug down. We're not going to torque them yet. And then what we're going to do is we're going to make sure that these cams still turn, because that's critical. This is always the moment we get nervous about. So you can see they're nice and smooth. That's what you want. You want those to turn, okay? Now we're going to start in the middle. 14 foot-pounds and work our way all the way out. And then the front caps, we're going to tighten those down to about 7.8 foot-pounds. 7.4, I think it is. Yeah, ends up being like 7.4. Okay, so those are torqued down. Now we're going to put the valve covers on. I'm going to show you, I do a little something here. So technically, the leak points on the valve covers are going to be right here, where the two metal surfaces meet together on both sides. So what we're going to do is I always run a bead of silicone all the way over the cam case and the entire head very lightly. I don't do the middle spark plug tube seals because those aren't necessary. But I do this because I've been building these motors for a big majority of my life, and every time I see a valve cover leak, it's usually in these areas, and it's usually because there's no silicone where it's leaking. So this little deal that I do here is this one of my little things that I do, and this literally keeps the leaks from happening a lot later in life on the engine. And I don't glob this stuff on. This is just a very nice, moderate coat of silicone, just enough to where it gives the gasket something to seal against, a little bit of forgiveness, I guess you could say. So yeah, so I've got it all the way around the outside perimeter there. And then we're going to put the gasket on the valve cover. So you want to go grab the valve cover and I'll take this over. So we got our valve cover here. Now what we're going to do, hold that for me, thank you. This is our gasket, got a brand new gasket. These basically sit in here in these grooves. They fit right in real nice. Subaru gaskets are the only ones that I use because they fit absolutely perfect. I've had some aftermarket ones, don't fit in the grooves very well and they end up leaking, and it's just not worth it. Then we got these spark plug tube seals that fit in the center of the valve cover here. No silicone required on these at all. These never leak until they get a million miles on them, pretty much. Okay, and we're going to set this on. So the valve cover is going to go on here, straight down, just like that. Now we're going to get the bolts. All these bolts are going to get torqued down to about 7 foot-pounds. You'll see after I tighten these valve covers down, you'll see the silicone just barely squeeze out around the edges. If you look, you can see just a real thin coat in there. It's perfect. That's what we want. So we'll run these down by hand, and then we'll finally torque them down with the torque wrench. Okay. Alright, the next secret that I'm going to show you guys with the oil pump. So I have my own little recipe here. We have a brand new oil pump from Subaru, and this one in particular is a 12mm oil pump. The reason why we're using this is because I had built this short block with clearances that are made to take advantage of this pump. You don't just take a 12mm pump, slap it on every motor. It doesn't work like that. So our motor's built for this. What we're going to do here is we're going to take this new oil pump all the way apart. So this back rotor plate here has these little Phillips screws on it. Now to get these off, impact screwdriver from Snap-on is the tool of choice. So once we pull this off, you can see this is the back rotor plate and this is the rotor. Now, these pumps are always shipped from Subaru dry. I don't know why they do this, but manufacturing cheaping out, but these rotors are all dry. There's no oil, there's no pre-assembly lube, there's nothing in this pump. So what happens is when you go to prime the motor for the first time, you're going to be turning it over at a very slow speed because you don't want to just dry fire a motor, right? That's why you put all that lube in there. But the problem is it takes a little bit of RPM to get this pump, to get the first suck of oil in it, to get it primed. So my trick, which after I do this, we'll get oil pressure in less than 30 seconds, cranking on a slow engine without it running, which is exactly what we want. So what I always do is I lube these rotors up with assembly lube beforehand, and that way it creates suction inside the pump so that when you're cranking it over without the spark plugs in it, priming it, it'll get that suction, it'll get oil pressure immediately, and you won't be spinning your motor over dry. This is very important. This is a very, very overlooked thing with Subarus when you're building a new engine. And your new engine can get scored up before it even runs without doing this. So there's a couple other things to note here on these pumps. There is some casting flash inside the pump here that you know, you can deal with. You can grind some of this down. There's a lot of mods that people do to these pumps. They can do a little tweaks here and there. Generally, these pumps flow more than enough oil than we're ever going to need for this application. You know, this isn't going to be a road course car that's going to see 9,000 RPM consistently all the time. So if that was the case, then we might look into a dry sump system where this might not be enough, because we're going to have high G loads and all that side to side. This is going to be a street car. It's going to be drag raced. Very, very short periods of time at that RPM. This pump will work fine. So you see a lot of people will get crazy and grind all this stuff out. They'll even try to enlarge this hole. You got to be careful when you do all this, because when you do that, you change the pressure drop in the pump, you change the flow, you change all kinds of things that Subaru spent time engineering this for. This pump is actually in Japan on the Spec C STI that revs to 9,000 from the factory. That's why they use this bigger pump. So Subaru has it figured out as far as this pump goes. They do a very good job. So one of the reasons why you don't want to put this on every motor and think it's going to do better for you is because this bypass valve in here has a spring pressure that bypasses oil. So that's what this does. Basically what happens is when the pressure gets too high inside the pump and overwhelms that spring seat and that pressure, it just bypasses it. So the oil comes in the pump and goes right back into the oil pan. It doesn't even go into the block. It bypasses completely through this hole. The bad thing about that is that heats up the oil. It superheats the oil anytime you're bypassing, because you have way too much friction. You have too much oil pressure. Friction is heat. You put heat back in the oil, your oil temperatures skyrocket for no reason. So that's why it's important to make sure the motor you put this on has clearances that are made to take advantage of this, and you're not just bypassing oil all the time, because that's not productive to the oil cooling system. So that goes into great depth as far as that stuff goes. I could spend an hour talking about that stuff, but just want to give you guys a quick overview here of what we're doing. So what we're going to do here is I'm going to grab my assembly lube. Where did I put it? Here it is. We're going to take a little bit here, and we're going to put it on the inside of the pump where the rotor sits, all the way around these surfaces here. Just like that, right? And then we're going to take it and we're going to also lube all the rotor vanes. We don't have to get crazy, but this stuff is really thick and it works really well, so it's really good at creating suction very easily. But then when we drop it in here with this lube, it just floats. It's just so fluid and smooth. That's exactly what we want. You also want to make sure these dots are facing up. They're both facing up to the rotor plate. That's important. So we're going to go ahead and we're going to lube this rotor up too on the inside. You also want to make sure this lube is perfectly clean. There's no dirt, no metal shavings, because that will destroy this pump. So you drop that in and everything should spin nice and smooth and be real hard to turn. You hear that? If you listen, that suction noise, that's exactly what we want. So we're going to spread this around now. Now we're going to be careful we don't want to get too much everywhere, because we got this rotor plate to put back on. So we'll keep the outside edge clean where the rotor plate has to seal. Just like that. That's all we want. Just a nice coat of assembly lube on that. And then we're going to go ahead and we're going to put this thing back together. So this rotor plate here and all these screws are going to go back on, and these are going to get torqued down to spec. So the spec on these bolts that I use is 8 foot-pounds. Need a torque wrench on here. You always want to make sure you torque these down, because I've actually seen these plate bolts come loose on other motors I've taken apart. And if that plate comes loose, you lose all oil pressure. And you're going to go in a crisscross pattern. Because you don't want to warp the plate. Because if you warp this plate, you'll lose oil pressure once again. This is pretty much the heart of your motor. This is what pumps all the blood through your motor. So imagine or all the oil through your motor. So imagine your body, your heart pumps all the blood. Without blood, you die. Well, without oil, your motor dies. Same thing. So this is very important. Just wipe it off. Everything looks good. Nice and smooth. See that, hear that suction. It's exactly what we want. We're gonna clock this like that because that's where we have our crankshaft set, and that drops onto the crank real easy. The one other thing we're gonna do is I'm gonna show you another secret that a lot of people aren't gonna show you. We're going to take this out. This is the bypass valve we were talking about. So this is something special that I learned a long time ago that I do. So we're going to pull this valve and spring out. We're going to see a couple things here. So this is our spring. This is the preset spring that makes this valve open when the pressure gets too big. And inside there's usually a shim pack. So this one has one shim. Now these shims are debated. This is a huge debate with these pumps. You see people cramming more shims in these pumps to try to keep the relief valve closed longer. That's not the right way to do it. These shims are actually made to calibrate this spring pressure against this valve to get it to open at the right time, not the right pressure. This opens at the right time. And what that means is when oil pressure comes up, as RPM comes up, there's a certain period of time where this valve needs to float a little bit to maintain the right pressure and keep the pressure stable. You don't want pressure spikes. You don't want your pressure to just go to 100 PSI down to 10 at idle. You want it, as soon as it gets up above 2,500 RPM, you want that pressure to flatline and stay nice and steady. And then as you get up to about 5,000 RPM or so, you want the pressure to jump up and stay flat. So this helps stabilize the pressure. That's important. So what we're gonna do here is, what I've learned over the years is, as good as Subaru is at making parts, they're not perfect. So this little valve here has some sharp edges sometimes. It's actually pretty blunt. What happens is if you get a little bit of trash in the oil system on a new motor, it'll get in between here and inside that bore, and it'll make this valve stick. And if this valve sticks, you lose oil pressure. So what I always do is I'll take some Scotch and I'll literally polish this valve. So we're gonna do, it doesn't take much, but we're just gonna give this a nice polish where this edge is. You can see the colors start to change. We're gonna polish this whole valve. And what we're trying to do here is keep this thing a little bit looser fit in there and a little bit smoother, because it's a very, very tight fit, which is good. You want it to seal, right? But the problem is when you build a motor, you can be as clean as you want. But if anything gets left behind, any metal shaving, any piece of dirt gets in this valve, you'll lose oil pressure and you will be very, very sad. So I've actually seen it happen on a couple engines, which really sucks. So now that we polished it a little bit, you can see the color on it. It's nice and shiny. And if you guys won't be able to notice this, but if you feel that with your finger, it literally feels like butter. That's exactly what we want. Now what we're gonna do is, this is something you gotta be careful with. So a lot of people are gonna say, well, let's pack that with a bunch of grease. No, you don't wanna do that. So with this valve, what you wanna do is you want oil. So you want a little bit of oil on the valve. You don't wanna pack it with grease. So we're just gonna get a little bit of oil. We're gonna oil it up. And we're gonna test fit it. And we're gonna drop it in. It should literally, if you just shake it, it should just drop right down there. You can see it actually falling down. And then what we're gonna do is we're gonna take our finger in here and we're gonna make sure it's smooth. You see it moving in and out in there? That's what you want. Nice and smooth, that means it's right. Put the spring in. Don't forget our shim, of course. Now, The reason why I don't pack that with lube is because it will make that valve hang up and open when it's not, or hold shut longer. A little bit of oil is what it's supposed to have in it when it's running. So we don't need any lube in there to make that harder and sticky. We want it to be butter smooth. And the other reason is too is because lube will attract metal and debris. And if we put lube in there, and for some reason we have metal and debris, it's going to be a magnet to that area. It's not going to allow it to pass through like it would if it was just some oil in there. So that's why we do that. Now we're going to take the bypass valve assembly. Now Subaru also ships this dry with just a ring to hold it from seal up. What I've actually figured out and found is when we're running a lot of oil pressure and we're running these engines real hard, these will leak. So just a very light coat of RTV, just so light, it's just for the threads. I mean, we're literally just giving just a skim coat. And what that does is that's going to help us seal just a little bit better and prevent leaks. That's snug. And there you go. That's basically, that oil pump is ready to go for the new engine. It's primed, it's lubed, it's gonna work good. The valve is polished. You don't have to do a ton of work to these oil pumps to make them work better. You just gotta do a little bit. Subaru does a good job pretty much on things, but there's just always the little stuff like those little tweaks that just make a huge difference. You don't want to reinvent the wheel here and just go crazy and start grinding this pump out, doing all kinds. I've seen more issues with people that do that than with the way I do it. So this is the way I do it. It's worked very well for me in the past. I've done a lot of testing over the years in my engines, lots of customer engines, and it works. And we don't have any issues, so that's why we do it. And it prevents those issues that do come up that I've seen. So now that we've got this cleaned off, we're gonna go ahead and silicone this oil pump. And what we're gonna do here is we're gonna run a nice moderate coat. We're gonna come around the outside of the O-ring. Okay, so you'll see how I do this. Now, a lot of people will go around this O-ring that goes in the block. That is not a good idea because that will literally clog up that hole, and that's literally the discharge to your block. You just want to do a nice coat around the inside of the bolt holes all the way around the outside because there's an O-ring on the block that's job is to seal that area. You don't need to silicone it. So now we're going to come over here to the block. You can see we got our new O-ring in the block. That's what I'm talking about. Now I have the block clocked basically at 12 o'clock on the pin, which that's going to put our rotors lined up with where we're at here on the pump. Now what we're going to do is we're going to carefully try to jiggle this on there. There you go. You'll feel it when the rotor lines up, just like that. We'll grab a rubber mallet. We'll just give it a little tap. Just like that. Nice and smooth. That's what we want. And then what we're going to do is we're going to come around to all the bolts. We're going to torque them to 7 foot-pounds. Then we're going to install our front seal, and then the oil system will be done. All right, oil pumps torqued on, ready to go. Here's another pro tip for you. These O-rings that go on the top of the block here. Little pro tip for you. Take some lube. Doesn't have to be a lot, but just lube these up. You'll thank me later. The reason why I do this is because there's several reasons actually. When you push these down in here with a little bit of lube on them, they will stick in their hole like they're supposed to and not move on you once you do that. And the reason is because when you put the crossover pipe on, you're sliding things around, those can pop up out of that groove. You'll torque it down and you won't know. You'll start it up and you have a coolant leak and you have to tear the whole thing back down again. So, little pro tip for you. You're welcome. All right, well, we got the lube on there. And we have Emanuel, as usual, cleaning the deal. And we'll be ready to put the water pipe on here in a second. You got the water pipe ready?
I say she'll do.
Okay. Always make sure the surfaces on the water pipe are clean and free of old gasket material because it will leak. Guaranteed. So we're going to go ahead and set this on the block. Just going to set it there just like that. We're going to come down. We're going to connect our water hoses to the new water pump that we put on. So we've got a little snafu here though. This goes on the outside like that. Doing this one hand, it's a little bit of a challenge, but good thing I've done it a few times. Put these hoses on. These hoses are in excellent condition because we replaced them not long ago. Always check these hoses though, because these are a problem child. And they will leak if they're old and they have tears in them, and you will not be happy when you have to tear your new motor down to fix a coolant leak. So, all right, well, water pump's on. Water pipes are on. We're going to tighten all that stuff up. And then we got a surprise for you. All right, here's another pro tip for you. Torque wrench, knock sensor. Torque your knock sensors. Your tuner will thank you, trust me. Torque them every time. That is all. All right, guys. Well, she's all timed up, looking good. We got that HKS belt. You might ask why? Because it's purple. Why not? So, brand new AVCS cam gears on there. Always a great idea with a fresh build. All new timing components, including new tensioner, new pulleys, idlers, everything on the front of this motor is new. Oil pump, water pump. Like I said, going for this kind of power, we're not skimping out. We don't want any of these components to hold us back or cause a problem. We also put on the IAG timing guide, which is awesome. This keeps the timing belt under control. When it's coming around this pulley at high RPM, it can kind of swing a little bit. Now, a little pro tip for you guys. These guys on the corner, nobody ever talks about them. I see all the time people set these up wrong. This clearance needs to be checked every time you put a new belt on, because if not, and that drags, it's going to tear a hole in this belt. So general rule that I do on these is a nice thick business card in between, then tighten them down, good to go. This one, same thing on the OEM ones, but these are pretty much preset. But yeah, she's looking real good. Now for the surprise that you've all been waiting for. We do the honors.
Clear covers.
So IAG makes these really nice piece of jewelry, is what I call them, for your engine. Check these out.
I don't even want to touch it.
Check that out. Is that cool or what? So this is going to go basically over the front of the motor. And look at that. You can see in there. Isn't that pretty? We got all of them. Whole timing cover set, all clear. So I'm going to get these put on, and then I'm going to show you guys the finished product here in a second, because I can't do it with one hand. I got to put the timing gaskets on, and then I'll come back. All right, guys, check this out. How's that looking? Oh yeah, it's looking real good. Well, there she is. She's long blocked and she's ready. Excited?
Oh yeah, beyond excited. It looks amazing.
All right, well, hopefully you guys enjoyed the video. I'm going to end it there. It's late. It's after midnight. We got the long block pretty much ready to go. I just need to torque the ATI pulley down, do that process. I'll do that tomorrow. And yeah, she's just about ready to go in the car. We still got to put the killer bee pan and oil system on the bottom. Some of the spacers aren't here, so we have to go grab them. But other than that, the next video will be us dropping this in the car and doing the first start. So until next time, guys, we'll see you later.
Peace.